So it is starting a few minutes late. Sorry about that. I also hope that we can finish a few minutes early because 6:15 sounds awfully late for a long day of training. Definitely for me. I'm sure a lot of you had delayed flights and some of you from red eyes and it sounds rough. So hopefully we have enough coffee. We'll get through some learning about integrating developer workflows. So I'm Alex. I work at Aspect. My co-founder Greg is back here. We've got some booklets that we're giving away related to the thing we built in the last couple of months, which I'll talk about a little bit. This course is, I'm going to be showing some material from our training site. This course normally we charge for our customers, and so you won't need to follow along on your own computers anyway. I will also occasionally be illustrating things from the Bazel examples repo. So this is just on GitHub. We can use cursor here. I don't know if we'll end up doing any AI stuff with it or not. I know I have, maybe I'll switch to Codex just in time for some folks in the room. And this is what we usually give as our Bazel 203 course. So the way we have our training laid out is that first of all, we have, sorry, I should go switch over here to this learning tab. So I have like this series of 100 classes. Those are free. A couple of them I've got recordings. Maybe some of you have watched my Bazel 101 recordings. And we're trying to build those out for more languages. So I think maybe JavaScript is going to be next. The 200 and the audience for those is end users. So people who are product engineers, they just want to keep doing their work. For most of them, this Bazel thing is at best a promise of making things faster for them, but in practice, it's going to make them change things and make them unhappy. They want to learn as little about it as they have to so that they can stay productive, right? So those are intentionally kind of short. Let's hide a lot of details from you. The 200 series is for developer infrastructure teams. These are like those of us who have to learn Bazel in some depth. 201 and 202 are more technical, so not going to talk about those today. So the first one is like diving into Bazel details. And the second one is about how to write macros and rules. If you're interested in writing rules, Jay next door, I'm sure is doing a great presentation on that. I will not cry if you decide to go listen to that one. I'm sure it's going to be more technical. What we're going to talk about in today is in 203 is less technical and largely about dealing with people and the fact that it is hard to do migrations, not only because of the code, but because of all of the opinions and all of the engineers and their personalities that we have to work with to make changes. I've given this a bunch of times, and once there was a funny chat going on in the side window. Of course, I'm mostly doing it over Zoom. It's much more fun to do it in front of a live room of people. Somebody in the chat was like, "Oh, this sounds like, I'm going to check out for a while because this is going to be all about politics." And by the end of that section, they said, "Oh, actually, that was the most useful part because like, how do we do developer infrastructure is sort of a prerequisite for how we're going to make people adopt Bazel in new ways. Because if we can't change how developers are doing things, then we're not going to have much success making them use Bazel." All right, so yeah, Bill Corin was one of my favorite engineering directors at Google back when I started there, and he used to say engineering is pretty easy, but the people are the hard part. That's kind of the theme here. So a lot of what I'm going to say will be useful if you're just installing Bazel in a new monorepo, and maybe just as a show of hands, how many people are sort of in that stage of evaluating Bazel or trying to convince the team, but like it's not yet the sort of built system of truth for the code base you care about. So was that a third about? Cool. Okay. So very useful for you. It's also useful for folks who already have Bazel because migrations never end. We all have to go to Bazel 9 and Bazelmod. We all have a new code base that nobody has moved yet, like a team that wasn't convinced. Acquisitions, mergers and acquisitions happen. And so there's always like more code to Bazelify in the future. So we're never really done. So I think a lot of these practices still apply. Okay, so and I have a short blog post that's kind of a summary of our approach to doing migrations, and a lot of this comes from the Google SWE book that has a flamingo on the front by Titus Winters and a couple other folks from Google who worked on large C++ migrations. And the first of these is that we have to actually convince developers that they want to do this. And so if you think about a net promoter score being something that every startup tries to achieve, the idea is of anybody who's used your software, how many of them would, on the whole, recommend it to their friends? And, on the other hand, we want to avoid detractors. So they're the negative side of the net promoters. They're the ones who are going around sort of giving people a bad impression about whatever migration work you're doing. Human psychology, I would love to see like a psychology of build systems talk. Actually, a lot of the keynotes from the DPE summit by the Gradle CEO are kind of interesting about like cognitive load and like what science shows us. Humans are like really tribal, right? And so if you don't use Windows and I say here's a Windows laptop, how about you switch? Then you're probably going to be super mad. If I tell you to change editors, you'll say over my cold dead hands, will you take away my I don't know obscure editor of choice? Um, and we also tend to really jump to conclusions. We have the system one mind, which is the one that runs away from tigers, as opposed to the system two mind that's more methodical and like willing to rationally think through something. So why does this matter for Bazel? Well, the first reaction is always incredibly hard to fix. Right. So somebody's first impression could be a tribal one, which is like, oh, well, my language let me pick on Haskell for just a moment, since Andreas is here. So they, we do it this way, but you Bazel people are saying we should do something completely different, and like I don't think that applies to my language ecosystem, and so they're like inclined to not want to go ahead with the migration because they feel like there's some other tribe is getting involved, right? They also tend to it's often difficult to separate something that's just cosmetic from something that's an inherent problem. And I feel like at a conference like this, you look at code on slides and you're like, well, that doesn't look quite right. Is it just that it doesn't look quite right, or fundamentally are the concepts wrong? It's pretty hard to figure out. And so people are much more quickly going to look at the aesthetics or the ergonomics of how you've set up Bazel for them in their repo and use that to jump to conclusions about whether Bazel is good or not, right? I like to think of that as the frozen vegetables problem. If you've only ever had poorly prepared vegetables that went in a microwave and they're soggy, then you think vegetables are bad, and then you go to a really nice restaurant where they're prepared well and you realize that maybe you did like vegetables, you just didn't like the bad kind. Right? So we don't want to give people like the frozen vegetables and give them this bad sense about how the migration work that you're doing. So another example, they'll look at the error messages you're presenting in CI and decide that means that the system sucks. Well, it was really just that the error message was bad, but like the thing it was trying to tell you was legitimate. They could see one step that's slow and they infer the whole thing is slow. And of course, lots of us have had the experience that Bazel sits there for a while before it does the thing, and your other tool didn't do that, so it's slow, right? That's your first impression matters. And I think it's easy for us as engineers to then want to be defensive and argue and say, you are actually what you're wrong. Let me explain to you why you're wrong. And that doesn't actually matter. Like even uninformed wrong people are going to have just as much influence in an organization of human beings, right? And so it's not enough to give people a wrong impression and then correct it. They need to get a right first impression. And yeah, your job later will become much harder once people get entrenched with this. So I'm always going to try to tie these sort of philosophical recommendations into something specific you can do for Bazel. So for a new CI check, let's say you want to roll out a new invariant. So you're like, okay, formatter, like now you got to format code in Rust. If you don't run Rust font on your code, like we're not going to accept it. It's going to be red. If the first thing you do is like you throw up a red PR and you're like, no, you didn't do the right thing, then you're going to make people like net detractor the first time they encounter this, even though like maybe your goal was good and the way you set up the formatter was good, but just somebody's experience using it was not good. But you can easily flip this around. If you're thinking in this terminology, you need to show them, A, I found a real problem that you might care about. And formatting is questionable whether somebody cares, but definitely for linting and finding other kinds of bugs, they're like happy that you found it. But then more importantly, you tell them exactly how to fix it. Run this command, or even better, click this button to accept the fix, right? And you do a little bit of extra last mile work so that instead of putting an imposition on this person for the new invariant you're rolling out, you're actually helping them. Like you're giving them like a benefit, and then like they have a positive experience. So yeah, don't throw roadblocks in front of people. Make them be enabled, even though that is extra work for us to roll out a thing, right? Because like the thing I rolled out was fine. The way that somebody interacted with it was not fine. So this company, GetDX, we've talked to them a little bit. We tried running one of their developer satisfaction surveys. They were recently acquired for like $1 billion, which in the developer infrastructure space is pretty exciting that kind of thing happens. What you can do is run a per developer satisfaction survey like as bookends before and after a migration. Another way you can do this is just run a single survey, but have a way to separate the population into developers who've been exposed to the new migration. Let's say it's Bazel versus the population who hadn't, and see like which metrics are noticeably different. Ideally, you get somebody who's good at statistics, better than me at picking apart what the data is telling them. Okay. So we want to convince, especially the people who have the most influence in our organization, the thought leaders, like they need to be convinced. So a lot of these are going to talk about how to convince that person, but let's keep that in mind. That's our goal. So first of all, we don't want to disrupt the workflows that they already have. And so one way to think of this is keep the make file. If you have a make file, you can keep it. So the same is true for, in the NPM and Yarn, they have task runners. For a lot of languages, there is a sort of canonical, like, I'm going to go run this command first. And in some cases, you can interject what should happen when that command gets run. Especially make is a general purpose task runner, so that's pretty easy to do. Something like go run is probably really hard because the go tool is pretty opinionated about exactly what it's going to do. It's not supposed to be a generic task runner. But where possible, we want to try to preserve the topmost user-facing part of what the developer is doing. First of all, they don't really care about the build system details. You might say, "Hey, we rewrote our tool in Rust. Isn't that great?" And for them, it's like, "No, that sounds like churn. Like that's not a feature. That just makes me worried. Now the tool doesn't have any. It's not mature anymore. Now it's like greenfield code, right? So what we want to tell them is you're not going to get them to be excited about your build system change. So we don't want them to have to type something new. We don't really want to make a big deal that it's new. We might want to say, "Hey, things got faster," or "You're going to be more productive with the thing we just changed." And also just finger memory. There's certain things I'm just so used to typing. And then I try to type something different. I was trying to type Basil followed by a C, and I automatically typed RC because Basil RC I type all the time. So don't retrain people. This includes in the editor, and I think this is probably the most practical example. I did the Python thing earlier today. The lesson from that was, hey, we can make our editors work again if we just make a standard site packages folder under a virtual environment and point the editor at it. And then all the other tools are going to be happy too, because that's what they expect. I think Bazel disrupts developer workflows, especially when in certain ecosystems where workarounds are required. So Go packages driver is a good example where Go tooling expects to find dependencies installed in a certain place. And one way to fix it is to change the editor and tell it where to go look. And there was a big effort, I think, in the Go community first to make it possible for the runtime to be told where to look for dependencies. And then somebody built an IDE plugin called Go packages driver to tell it where to go look. That's a ambitious project. From what I've seen, it doesn't always work very well. The alternative is just put the files where the runtime expected them to be, right? So for rules.js, for example, with NPM, it expects the dependencies to be in the source tree. So we tell you to just put them there, right? And you can use patterns. We'll talk about the write source files pattern later to actually check files into the source tree if that's where the editor expects them to be. So yeah, don't disrupt workflows accidentally, and it's always better to not break them than to break them and then try to fix them. Is my experience. Okay, so I'll talk about watch mode for a minute. Especially for front-end developers, they're used to having a watch mode, and it really disrupts their workflow if you take that away. There's a thing called hot module reloading, which is even better than watch mode, which is I leave the server running, I leave the web page live, and just the bit of code you changed is now that's visible when you click the button again, but I didn't have to re-navigate through the application. A lot of runtimes have this. I remember working at Google in Java, there's a Java Rebel JRE probably still around where you can hot swap in method bodies, right? And that could be a legitimate productivity enhancement, and you shouldn't break that when you're doing a migration. So yeah, you can use iBazel. I mentioned earlier in the Python thing, but it's already on the path thanks to dir.env. And just since not all of you were there, I'll briefly show this again. So in the tools folder, oops, sorry, that's under Angular. So this is the Bazel examples repo. I encourage you to check it out on GitHub. You can send pull requests to it. We do try to, a lot of times I'm helping a customer figure out how to do something, and I'll try to put the answer here so everybody else can find it. This has a tools folder. It's a big monorepo with lots and lots of languages in it. And the relevant bit is that this Bazel env setup is a way for Bazel to manage your developer environment. So a lot of changes that you want to make to developer workflows requires that they be able to type something on the terminal. And getting things rolled out to all of your developers on their machines is pretty hard. Unless you have a really good MDM solution, which is mobile device management. Like it's usually for like, people carrying, like I lost my iPhone, new generation at a bar in Palo Alto, and now like it leaks to the press that Apple's making a new device. Okay, that's an extreme example, but like we all have some sort of corporate management software installed on our laptops, which is mostly getting in our way, but in theory can be used to like also roll out software to our machines. I tried to set this up for an earlier customer we worked for. It's pretty hard to work through those systems. They're not really intended for developer tools. Bazel is, right? So this thing, Bazel N from Fabian at BuildBuddy, is amazing. And it's basically a set of, I need all these things on my path, Java, Node, PNPM. And then where to get them from can be a label that lives out in third party somewhere. So like the Go tool, I'm using the same version Bazel is. I can also get the same version of Java that Bazel is running, because it comes through as a toolchain variable. Same thing for SDKs. So I can get the JDK, the Python SDK, the Node.js SDK on my machine at a stable path. So I'll just do a quick demo of how this looks. Tools, Bazel, env. Right now it downloads all the tools. It should be more lazy. Aspect CLI download. Well, that's a sad one to fail, because definitely want to show that. I'll show that in another repo maybe. So this is using rules multi-tool, which is toolchain aware. So it sets up, it only downloads the things for the platforms you need. Yes, unfortunately, I could have prepared this ahead of time. I'm going to trash the Wi-Fi that all of us are trying to use. Maybe I'll show some of these demos in a GitHub code space instead, which I have from earlier today. And then all of this stuff is happening on somebody else's network. Yeah, conference Wi-Fi, you should not count on it. Okay, that'll boot up. So yeah, I'll show what this thing looks like. So the takeaway here is like something like watch mode is available under Bazel, number one, right? So if your developers expect it, don't take it away from them. And number two is, this is the first of several examples I'll show where in order to solve this problem, we may need to get a tool on their machine. And so it's really important that you have a way to get things on the path. As I said earlier in the Python one, you don't want to write a README that says, oh, you just need to run iBazel something. And then asterisk, if you don't have it, here's some install instructions that may or may not work for you, or maybe you have an old version on your machine. And there's just so many ways that people are going to trip over that. And as a result, we're not going to have a nut promoter. We're going to have somebody whose first experience was that I had to do some fixing on my computer before I was able to run the command that was in the README. And we may have lost that person. Okay, another exercise we could show is running a live dev server. Really the point here is that, I guess, how many people are using iBazel already for like having a watch mode? Just a couple. So normally iBazel will restart the program every time there's a change. And depending on what the program is, that could be very slow. Most, certainly for front-end developers, they expect to have a dev server as part of the stack that they install. And that dev server is expecting to stay running, and then just, as source files change, it's going to do something. Most of these dev servers accidentally became a build system in their own right, because they're watching the original source tree, then you changed a .rs file or a .ts file, and now there's a whole bunch of work to do before the server can show you the new behavior. And so, what are they going to do? Well, we don't have Bazel rolled out to the whole world yet. So they're going to either run the idiomatic build system for that language, or they're going to make their own build system, which a lot of JavaScript tooling has done. So the takeaway from this is that iBazel has this protocol called iBazel notify changes, which you stick as a tag on the target that's being run. So you do iBazel run, and the target has this tag on it in the build file. That tells iBazel that it doesn't need to be restarted. It has a protocol where over standard in, it will be told which files changed. Actually, let me be more correct. It will be told that files changed, and now, go do something to update yourself. Unlike the Bazel worker protocol, if you've ever written a persistent worker, it has access to which files changed. We've been working at Aspect on improving this protocol so that it does know which files changed, so that we can be smarter about doing live reloads. And that is coming in the Aspect CLI, as well as we'll have to stitch it into some of the dev servers we work on, so that we get a much faster round trip time. And the dev server, anything that's in the hot loop is the place where you can afford the least to have a regression on performance. Cool. So I was going to show that, but I don't want to like do something that's going to rely too much on the Wi-Fi working. Let's just see if we can. I mean, I have the one I was doing earlier today, so let me make this a little bit bigger, just for sake of demonstration. So, um, again, I'll do Bazel run tools Bazel env. Um, so this is a step that developers can choose to do to get their path set up correctly. Oops, I did not mean to change Bazel versions. Sorry, I was doing something in the last talk. Um, This so by the way, there's an envrc file in this folder. This is another thing that you can, if you go look at the documentation for Bazel env, they mention that you can wire it up with this tool called direnv, which looks at this file. So these lines here will actually make it so when I cd into this folder, I automatically get my path environment variable set up with all the tools, and then if I leave the folder, then it will unset those variables. So it hooks into the shell. Yeah, iBazel's in this file. Yeah, I'll come back to this demo. Okay, so there's a bunch of different things developers are expecting to work, so we can't disrupt those. Okay, so changing one thing at a time. More than you think, I guess. I think, probably all of us are like, oh yeah, that sounds good. We shouldn't like make a whole bunch of changes in the same PR, but in practice we often do. So I want to bang on this drum a little bit. Build system changes tend to cause really subtle regressions. The cause and effect may not be really near each other, so there's like spooky action at a distance going on. We're changing, we're plumbers. We're down there changing SDK versions, and maybe, we make a change that affects the ordering of the class path on some Java program, and like subtly bad things happen. Multiple transitive closures of Python requirements get brought into the same runtime. Which one wins? Very subtle problems. And the other thing is there's like a distance not only between the change and the place where it affects, but also the organization that we live in as developer infrastructure and the product engineer who's going to end up having this problem. They're going to be like, stuff is broken. I got this crazy stack trace from a layer I've never heard of, and you're like, I've never heard of your whole program. Like I didn't even know your team worked at our company. And now the two of you are like, are now, on a mission to fix this problem together, which is most of the time just you have to revert because you don't understand what they're doing and you can't be in their way. And so, first of all, you want to be able to bisect this. Like you want to know which change you made broke them, and like very easy to compound several changes, especially because those product engineers aren't doing that workflow every single day. It may be that you made a change a few days ago. They hadn't rebased their Git checkout past that point, or that's just they only need to regenerate the protos every periodically for whatever reason, like they just don't touch that part. So having a linear commit history, like some people love merge commits. It is possible to bisect with merge commits. It breaks my head, so I prefer not to. But you want to be able to like essentially contain the blast radius to like last known good state. Only change I made since then is the following, so like I'm pretty sure that that's what it is. And so that's why we want to change one thing at a time. And there's two words that I would love for you to come out of this section of the talk with: prefactoring and post-factoring. So we often do like refactoring. Okay, well that's just a change for its own right. Prefactoring is, oh, I'm making a change and I noticed that I also wish I could update this dot file. Like I'm working in rules.js and there's a .npmrc file and I could put hoist equals false in there. I could do that at the same time that I'm rolling out my Bazel stuff, but that setting works equally well with the legacy build system. So I have the opportunity to prefactor. I could make that change, land it, let it bake for a little while. Again, it's hard for me to tell what I've broken, right? A lot of things developers expect to work aren't even tested on CI because accidentally we wrote CI scripts that are different from local dev scripts and they behave differently. So I land the prefactoring change, and then after a while, then I can make my Bazel change smaller, right? Similarly, you can use post-factoring, so you can say, oh, it looks like I'm going to want to fix this thing. I don't want to do that before I make the change. I can tolerate that state during the change, but I'm going to like make a note somewhere. Maybe I make a PR and I throw it up as a draft so I don't forget about it, whatever you use as your to-do system, to come back and like, okay, now we'll be able to remove that thing. And I'll talk about like finishing migrations. Like you definitely need to be able to remove the thing. The problem is it's so easy to just think, oh, it would be a pain in the butt for me to make a new branch locally, and then like my Bazel like repository cache is going to get busted because my new branch is going to be at head, and then I'll make this like 2-line change over there, and I'm going to spend all this time sending that for review and trying to get people to approve it. I could just put the 2-line change in the PR that's already about ready to land. It's already green, and I got a review stamp, right? And yeah, like I wouldn't fault you for taking the choice of including those two things in the same commit, but really the answer should be, I can go into a one file edit mode, and I do this a lot on our rule sets. I maintain tons of open source repos. Just go into GitHub, press the pencil button, like copy the 2 lines you want into there. It should be pretty easy to make like a one-off ephemeral development environment just for a change. Maybe you don't have an easy way to run tests locally. You're going to rely on CI to run tests, but like, if I found a bug in this file, in the earlier course, you found a bug in another file, I could have just pressed the pencil button. And the point being, if you don't have an easy way to make changes like that, then your users don't either. I think it's really wise to invest in a way to, if you're using GitHub, then the pencil button maybe just already works for you. If you have some other version control system, like, I don't know, in Garrett, whether there's a quick way to like spin up a change, but if you want to be able to easily make this sort of one file edit workflow. Okay, so if we've done this right and we've only changed one thing at a time, we can go back and rewatch the BazelCon talk from the very first BazelCon where SpaceX showed up and they were like, okay, so we launched these rockets, 50 million when we blow them up. So what we do is we ran our old build system and we like looked at all the bytes of all the outputs, and we ran Bazel, and they better be the same, right? So we should be able to have that sort of identical before and after flow. Bazel build dash subcommands is another example. You could run your legacy build and be like, okay, these are all the flags we passed the tools. Now when I do it with Bazel, do I get the same flags? If the flags are different, why? Did I intend to do that? And then the next thing you should think is, if I did intend to do that, can I do a prefactoring to introduce the new flags in the old system so that I'm less likely to have Bazel be the thing that breaks something? Right? This is also a little bit of like shifting blame. It's like, I could have passed those flags to the old tool, and if it breaks something, users are like, oh, the old tool doesn't behave well with those flags. But if I do it with the Bazel migration, they're going to say Bazel sucks. And you're like, no. It was the tool behaves that way with the flags, whether it's Bazel or not. Right? But again, human psychology, we tend to conflate things. That's our system one mentality, trying to figure out, is the thing a tiger? Yes, I start running away. I'm not going to try to figure out like whose layer the flag actually applies to. Okay. So changing one thing at a time may sound like an awful lot of toil and juggling a large number of PRs, and it can be. The place where you get a lot of power from that is this ratchet mechanism. So I like to strap things on the roof of my car because I go up to the forest and I take things that don't fit inside the car, and so I use this ratchet tie down thing. Maybe some of you have hobbies where you get to use an appliance like this. It's like the no backsliding tool, right? So the first part is that the piece number one, you have like a big lever. So you have a lot of leverage to turn piece number one. And imagine you have a giant monorepo where like, oh my God, if I have to change an SDK version, I'm going to touch 500 engineers' code in ways that are going to be impossible to fix. Like you need, like that sort of, think of that as a really heavy impedance problem. Like moving this repo from one state to another takes a ton of torque, and if I have a long lever like you do for this kind of ratchet mechanism, you can move piece number one a single tooth with a fair amount of effort, right? And so if you think about this in a monorepo, maybe what I want to do is to change one thing at a time. Let's say I'm introducing Python type checking in my repo. Instead of turning on the entire type checker for the libraries, I turn on one diagnostic code at a time. I'm like, okay, you're not allowed to have, like int try to cast a string. That's it. And I turn off all the rest of them. My entire effort is now focused on moving this thing one tooth, which is that one diagnostic code. Okay. Piece number two is critical. If you've ever tried to do one of these things, like you ratchet it one step, you can't then have it fly back because like it gets under like a lot of pressure. So piece number two is your backsliding prevention. So in the case of a Python type check, for example, you would add a new CI step that's like, I'm going to run the type checker. I'm going to throw away all the diagnostics it produces, except for the one that I've said is now like required in our repo. And now you're sure that, it's a lot of effort to land the PR that actually enforces this for everybody, but now nobody's going to introduce new code that breaks it. Right? And there's an even nicer way to do this where you introduce piece number two first. You create a list of all the problem spots. You just do not a Bazel query per se. Maybe you have to do something in the language ecosystem. Maybe you make the change, run the build, get a jillion build failures from Bazel, and then you do a little bit of post-processing on that to create a list of all the spots that are problems. You allow list exactly those spots, and you turn on the enforcement. So the only spots that are allowed to make the mistake are the spots that already make the mistake. Now you can just like burn that list down one step at a time, but you know that nothing new gets introduced, so you're not chasing a moving target. Okay, so yeah, so fixing the CI system combined with one change at a time, this is sort of giving you this mechanical advantage. I probably beat the analogy enough at this point. And I should be stopping for questions as I go. Anybody have any questions so far? Make sure you're all awake. Yeah, Dan.
What happens if you've already made a bad impression?
Yeah, that is a good question. It's definitely not in the slides, but I think it's worth spending some time on it. So I think the most important first step, I think most engineering cultures are based a lot on credibility, and you can restore your credibility first by being transparent about like, okay, the thing we did was unproductive for you. And there's no point being defensive again, right? Like you can't be like, oh, well, you don't understand. This is better. It's just not better for you. I think it's better for the world. It's more hermetic, don't you see? So I think a good first step is like to offer to revert. Like you will make a friend immediately if you revert the thing and you're like, hey, I would love for your help to roll this forward. You don't have to commit to sign up to rolling it forward, but I am taking your feedback serious enough to revert. Now, if we're like several months into a Bazel migration, it's hard to say we're going to revert the whole migration clearly. But if there's some like less bad state that you can retreat to, I think that's a good first step. Developer satisfaction survey will help you to find this out sooner. So I think another problem is like developers are hating it, but you're just not noticing. And is this a technical Bazel problem of getting developer feedback? Well, it's kind of a stretch whether it belongs in this talk, but there should be a cadence of like getting feedback from developers. It's also useful. I'll talk about putting error messages in the right spot, but you can put feedback mechanisms in the right spot, which is to say, when something fails on CI, is there a button that the developer can press and say like, oh, well, like I've seen this check fail like 4 times and it was never actually the thing it says, right? Now you have to sign up for accepting and like processing feedback, which is itself kind of hard. And I think probably the other answer is try to give we broke something, right? Which was like, don't disrupt workflows. Can we like give the engineer a chance to move back to their old workflow? So say like, hey, like we're going to okay, fine, Bazel's optional. Like you can still run it the old way. We will restore some of the configuration files that we took away so that you can still run it the old way. Yeah, question.
Maybe let me explain. Let's say it may be failing only for 1 or 2 developers. Rest of them it is perfect. So then we don't want to roll back. So
yeah. Okay. So the question is, what if only a very small population is having a problem with something we changed? So, of course, Bazel is supposed to be reproducible, and so that should be impossible, right? Like everybody gets the same behavior. In practice. Okay, so I think one example is their machine is set up differently, and this is going back to like Bazel env and other approaches to try to make everybody's machine the same. So like one of the things is let's root cause it. How is it that your thing is possibly different from somebody else's? And this is assuming you're both doing the same use case. So like you both start at the same commit, you run the same command, one of you gets a different result than the other. That's one of the problems Bazel's here to try to fix. So we should try to make it more reproducible. But then there's also like, oh, there's this other use case. It's just that nobody else is trying to do it the way you're trying to do it. Fundamentally, that kind of thing comes down to a negotiation between like, what does your team guarantee about the kinds of changes that you make in the monorepo, right? So I'll talk about like keeping the monorepo green. You could say, hey, you could have had a test for that. This is the Beyonce principle. Like if you liked it, you would have put a test on it. I don't know if it's aged very well. There used to be a song. I guess there still is. So, and at Google, like that was largely the bar was like, if your thing is broken and you didn't have a test for it, like we might roll back, but like we're going to roll forward again at a certain fixed time, and it's up to you to add the missing test or whatever. And yeah, I'll talk more about like defending your ability to operate at scale, but it's very important not to allow special snowflakes like this to pop up. So yeah, either that person's use case needs to be one of the use cases we guarantee, or they need to stop doing it and they're on their own.
I don't know. I think
Yeah.
some people use Emacs, some maybe green, then a different ID, there are different outputs, problems.
Yes, supporting multiple editors. So when I said like let's leave the files alone, so Go packages driver as an example, I might have some developers in Goland, which is the IntelliJ, the JetBrains IDE, that are working, and developers in other editors are like, this doesn't work anymore because the Go packages driver thing doesn't work. I think the answer is, at what point did we break the Emacs users? Right? It was when we stopped putting these files in the place that the language server expects. That was our mistake. We should leave them there. And so the editors, like, yes, editors have different extensions. Like the plugin for VS Code behaves differently from the plugin for PyCharm. And like for that, you can be like, hey, like contact the upstream maintainers. That's not something I can fix for you. But all the interactions between the build system, especially like the way Bazel lays out third-party packages and the editor, or even just links to first-party packages, like we should make them the same as what that editor saw before Bazel.
Thank you.
Yeah. Yeah, and of course I'm like super generalizing, right? Like I'm not digging into any particular language. I'm trying to throw around examples. Some of these things you get more mileage on in one language than another. Okay, so BazelCon 2019. Greg, do you want to come back up and we'll like redo this talk? I've got the video here and everything. Yeah. So, so this is the mathematical thing called gradient descent. And for those of you who remember, I don't even remember which math class this is from. Algebra, I guess. Like, how do you like? Let's say you can't evaluate the result of a function. So, like, the height of the hills here is like a function applied to some inputs, right? And in our case, the function is how good's your development story, right? Like, how productive are engineers, or like, how good is our developer experience? So, complicated function to measure. So we don't know for sure of every value of x and y, and of course this is a two-dimensional, but there's a lot of dimensions that go into improving developer productivity. So we're making changes and we're trying to tell if they improve things. And gradient descent is this mathematical thing that's basically go uphill, right? And you will get to a local maximum. Number one, why would you want to do that? Like the global maximum could be that hill over there you see that's even higher. The problem is if you go downhill for a while, and again, the downhill means like worse developer experience, you have a very limited budget before those engineers are mad enough to tell your director to stop the migration because it's harming their ability to ship the things that they promised this quarter, right? Business is business. So it's rare. I love somebody from Lucid was here today. I don't know if they're in the room. That's you guys. Okay, so you remember your TypeScript migration?
Yeah.
Okay.
Well, I wasn't there then, but I know of it.
Okay, so one option is you like for gradient descent, they were like, hey, there's a taller hill over there. We're going to give ourselves 72 hours to go downhill, across the river, uphill to over there, because by the time Monday morning rolls around, our engineering team had better be up and running on the new thing. Okay, so they introduced TypeScript. They had it's great. They had a hackathon. They did this over the weekend, right?
My favorite strategy.
Yeah, so you're like the whole point here is like we have to change we can't like stop the car, right? Software development has to continue at our company. So like if you stop the world, then you got to have this incredibly fast pit crew team. Okay, so that's what they did. 72 hours, they changed the tires on the car. They didn't lose the race because they were fast enough that other cars had to stop too. So it was okay. Most of us have to do this one, which is fun. I mean, look at that. How could you not have fun? I wonder how it would be to try doing that in an actual car. So like my point in gradient ascent is we may not be able to get the best possible thing because doing the thing on the top, like there's only so much we can change at a time. We can change one tire at a time maybe, and stop the world is just too risky for most of us to do. Our migration work will get stopped midway through. So like if you leave a to-do, like, yeah, the performance regression will be fixed real soon now, right? And then like you get new priorities or you were never very good at really knowing your priorities to begin with, then like real soon now doesn't happen for a while. And then like engineers are mad and you're like, yeah, I know. I'm going to fix that like real soon now. Like you can't get into that business. And so that's why I think gradient descent is both a necessity, and also, if I can make you feel better about the global maximum, you will have another job after this one. You'll have another chance to like do everything the better way. So I don't know. Maybe the code base you're in is not the time to do that. Okay. A lot of migration work we do, and it's not done until, let's say, we delete the old thing. So I love like agile methodologies where you put index cards on the board and you're like, okay, let's make sure for every one of the tasks when we say it's done that it's actually done. What does it mean to be actually done with a migration project? Usually there's uh, Helen and I were just joking about this earlier, that you have like engineers come on Slack and ask you questions, right? And if you still get questions about the migration that you've already completed, then something is wrong. You have to defend your ability to start working on the next thing, and you can't be always supporting the thing that already landed. And so if you answer somebody's question on Slack and they say, "Oh, okay, yep, thanks, got it. Like the README was out of date. You have to install, Python version 3.10.1, not 3.10.2," and then the problem goes away. Have you solved the problem? Well, like somebody else is probably going to trip over the same thing. So one thing that you have to do to close the loop is figure out where the error message, where does the help need to go? So it shouldn't be in this one Slack message. You could, okay, next step, let's just brainstorm. Oh, I'm going to pin that Slack message. Now, anybody who comes to this channel should be able to go through the list of pinned messages and find this one. It probably only works for the first like 2 or 3 messages. We could go add it to the documentation. Which can help, right? Some people will go look for documentation, and if using a good, like, maybe even AI powered like search indexer over all the documentation, including comments in your source code. I've seen some companies that have like a pretty good ability to do like information retrieval essentially out of comments or out of markdown that you've written in the repo, or maybe it lives in a wiki. So that can help. And of course, even better, it means that if you do have to answer the person on Slack, you just send them a link to the thing, which is really more like the RTFM answer. But at least you've convinced yourself that like the documentation is there, this person will go read it. The best answer is like asking them, hey, where would you have noticed this? And it depends how much time you have, right? But somebody comes on Slack and they're like, oh, I would never have figured that out. And you're like, where would you have looked? Right? Which wiki page would you have looked at? Even better, what was the error message you saw? And maybe it's more work, but you can actually introduce error messages in code that you write, or even patch the error messages that come from third-party code to at least have a Go link or some context to help more people be self-serving. And yeah, that will just increase your velocity later. It's an investment today. Answer questions in the form of documentation. Takes a little bit more work today, but it will pay off. Bazel in particular has ways of improving. Validation actions. Everybody know what a validation action is? This was added. Yeah, I love them too. I think they're added in Bazel 7. So a validation action is basically the output from this thing is not used, right? And normally Bazel only does the minimum amount of work necessary for the outputs you request. And so in the past, you had to sort of, in order to run some validation step, you'd have to be like, oh, the validation step produces some marker file, and then the marker file somehow gets injected into the final, whatever it is you're building, so that you can't help but make Bazel try to build it. So validation actions fixes this. It's a way of just saying, hey, I can easily, and you can do this even in an aspect. You don't have to modify the rule definition. You can basically make an aspect that visits the graph and it sees a certain condition, and it can like hard fail, so like fail fast, right? So hard fail on this case instead of like failing later or failing with a bad error message. You can constrain legal values for attributes. So a lot of in a rule implementation, you have and Jay's talking about this next door. You have like an attrs list where you can say like, here's the valid values that I permit. You can fix error messages, get in the habit of improving documentation. Improving documentation, by the way, comes back to the thing I mentioned earlier. If you don't have a way to make a single change to a file real quick out of band without changing your local Git state, and send it off for review, and ideally never have to look at it again, right? Like auto merge is turned on, and when it gets reviewed, it goes in. Like you're going to have a hard time also improving your documentation, because every time you answer somebody's Slack message, you're taking an interrupt. You don't want the interrupt to turn into 20 minutes. So you're willing to hit the pencil button and spend 2 minutes answering their question. Yeah.
I was going to say, we have some validation actions, and one of the coolest things in my opinion is that you can Bazel build, keep going, build all the stuff, run all the validation actions, see all the outputs at once, and then we have a script that will like go through the log, look at all those errors, and then try to fix as many of them for you. And it creates a really nice developer experience.
Yeah, so I guess I should repeat a little bit since there's a recording. So you can run a validation action with dash dash keep going and collect a lot of errors in one run. And then, so you have like end users who encounter this state and then it tries to give them fixes for these things.
Yeah, you just go through the basal log because they'll be logged there.
Yeah. Yeah. I mentioned like um, Python type checking rollout earlier. So we had to do one of these at Google for TypeScript. And you can turn on one diagnostic code at a time, but you can also produce suggested fixes in that same situation. So yeah, if you can take your list of error messages and turn it into a list of deltas on the code, by the way, kind of a fun project. You know, most of us are into compilers, at least, you know, in principle. You don't have to do anything too difficult. You get to like read an AST and like find an offset and like inject some text. And yeah, you can actually use that to close the loop, right? And to come all the way back to like my error message helps you to fix the problem.
Have any examples and validation steps you know?
Yeah, that's a good question.
Maybe like
What's a good validation action? I mean, I have an example that's on my to-do list.
okay.
Um,
Rules TS use.
Rules TS has some. Yeah, I was. So there's a magic thing called underscore validation is the name of the output group that you use, right? So anything that returns an underscore validation inside of output group info, these are the outputs that Bazel will build whether anybody asks for them or not. Although there is a flag to turn on and off validation in general, right? So developers could skip it and like just turn off validation. So this one, the validation outs that we produce are the type check outs, so that you can use TypeScript type checking as you know, in this case, rules TS allows you to do type checking out of band from running tests or setting up the development server. So this is one way to make sure that developers see those, even if the dev server build target doesn't depend on them.
One thing I will say, this we learned this the hard way, is when you run an aspect on your build graph, by default it will still run validations, and if your validation depends on like your main compilation or the really heavy action, and you don't supply the no run validations flag, you can just throw on that aspect and it will do a lot of work that you did not want it to do.
Okay. Yep. Hopefully, this like the scenario you're describing is that you as developer infrastructure are doing an experiment to turn on an aspect that you're not turning it on for everybody. Yeah, it could be expensive. I remember that actually the great example of this is that we made this linter setup, and let me see how quickly I can find. Oh, I should just search in here for under validation. So basically, like we wanted a way for linters to fail. In this case, like they're not being run as test targets, so we wouldn't normally ask for this. You'd have to like explicitly with rules lint, you had to explicitly ask for one of these output groups. But all I had to do in a very small PR was also output that thing under underscore validation, so that that output gets produced all the time by Bazel. So that if it fails, which it would if a linter returns non-zero exit code, then you can get the build to fail. I just have to revisit that PR because it was so delightfully small. Like just remove some code out. Like it's literally like just adding that one line, right? Underscore validation in your default info. Yeah, and then you can tell people how to do it with dash dash no run validations. Yeah, good. Thank you. Yeah, I'm happy to show more examples of things too. Okay, so those are some ways to avoid people asking you questions. There's one other thing about like the definition of done. A lot of times we have an old way and a new way, and like broadly speaking, the old way might be CMake and the new way is Bazel, or it might be something more subtle, like the old way was you're going to run this command for formatting. We have a new command for formatting. You want to keep both ways working at the beginning, right? So there's going to be sort of a three-phase migration. You introduce the new thing, you run in parallel for a while, you burn down most of the usage, and then you delete the old thing. So it's very tempting to never delete the old thing because, you know, we only got so much time. So you got to think about this in terms of a complexity budget or a technical debt budget. When we did TypeScript at Google, my TL for that was like always talking about like, you know, we can't add more complexity unless we remove complexity somewhere else, which I think is really wise. If we don't remove the old way, then like we're gonna possibly have more occurrences of the old way showing up. So people are going to keep depending on it. We can use the thing I mentioned earlier to try to only allow list the existing occurrences. But but also like by removing the old thing, like you may finally be able to drop some stuff that you've been supporting. All of us are looking forward to deleting our last workspace file, for example. Like that will legitimately save us a bunch of time from then on of trying to like debug loading order problems in Bazel repository rules. So yeah, I don't know. Like it's hard to be disciplined and convince ourselves to finish things, and managers want to get on to the next thing. So yeah, thinking for the long term. Okay. Any questions yet? But thank you for injecting some as we go. So let me talk about leaving code alone. So I said earlier, we can check files into the source tree, for example. We shouldn't have to make people change the way they're loading things. It's often the case that Googlers working on using Bazel inside of Google 3, the big monorepo, it's really coupled with a lot of other assumptions about the way things work there. Single version policy, like you're only going to have one transitive closure of dependencies. They're all going to be checked into the repo. We never put output files into the source tree. They always go into the Bazel gen files. They got rid of Bazel gen files. My understanding is they kept the Blaze gen files folder, which feels really unfair. I would love to have it back. I just want to encourage everyone to challenge the dogma that comes with Bazel and be like, does it really have to? Somebody was asking at the end of the last session, my builds are really slow because of setting up the sandbox. You don't have to sandbox your actions, especially on local development. And sometimes it's like Bazel interacting with package managers. We should challenge the assumption that like the code has to change. So just be like, well, why can't Bazel be different? Why if the code does have to change, try to find more superficial ways to change it. So Gazelle is a great example where you can add comments in your file to change the way it behaves. You can write your own Gazelle extensions that look for comments. You can, comments are kind of like a little bit weird to be load bearing. You kind of assume you can always delete a comment and the code shouldn't change, but sometimes tooling uses them. The nice thing is you're probably not going to break somebody's production code by adding a comment to their code, right? Dependencies, we don't want to change any third-party dependency versions. If we're the dev infra team and we're doing some sort of a rollout, we want all of the product engineering teams to still have exactly the same version of the dependencies that they're on today, not even like a patch bump if we can possibly avoid it, because if we break something, that becomes our fault. And they should be the ones that own their code. Like the blame layer is another good example. Let's say you run a formatter over the repo. You don't want to show up in the blame layer as the engineer who touched all this code. People are going to come ask you, hey, how does this code work? And you're like, oh, it wasn't supposed to be me. If you don't know about Git has a mechanism to avoid showing up in the blame layer called the Git ignore revs. I'm missing one word in there. Git blame ignore revs, right? So you add your commit SHA in there. You have to wait until you've committed it so you have a SHA. And now you won't show up in the blame layer, but on the GitHub UI and I think in local Git as of some version, it supports this thing. You can also avoid leaving fingerprints in an especially sneaky way, which is suggestions on code reviews. And I have sometimes made changes to a repo by suggesting it on somebody else's change, and then they're the author. It's like questionably ethical, but it does mean that like they're definitely not going to come back to me and ask about this thing. And like legitimately sometimes as developer infrastructure, like you're in the code owners of some file that's near the root. Somebody else is making a change. You want to fix their change. You can do that. Like there's nothing wrong with making suggested fixes in somebody else's change, especially if they are on the product engineering team that is more likely to be responsible for the area of code that's being changed. Right? You just want to like make it clear who's responsible and that it's not you. If you're editing a bunch of code in order to do some migration step, you probably are accidentally violating this principle. You should try to leave people's code alone. Challenge whether Bazel really makes you change the code. Okay. So that's the end of the first segment on so that's all my sort of philosophy. I feel like I'm just sort of like lecturing you about how to be good engineers or something. I really do think that our jobs can be a lot easier if we can get all the engineers to like do the thing we're trying to get them to do, like herding all the cats, and putting those kind of guardrails in place and like following their human psychology is going to make it a lot easier to do. So now I'm going to sort of pivot into more Bazel specific workflows like you probably expected to hear today. So the first one is continuous integration. So a lot of teams don't have continuous integration because it wasn't possible before they had Bazel, right? So if you have a full stack, what they often do is a continuous build. And we just all started using the term CI, and I challenge you to think about what do the C and the I stand for. Maybe you can even bring this back to your teams. The C is continuous, and I'll make a small digression. I don't think we're doing it continuous enough. If there's a person on your team who was never able to get their laptop set up right, or they're just casually contributing to your code base, they might be just making changes and tossing them over to the CI system and being like, okay, I'm just going to use the CI system to validate my changes. And you're like, no, you should set up your local development environment. Don't you have a local development environment? That person is right. They're doing continuous, right? Every time they make a change, they're like asking the system if the test still pass. And I don't think in our industry we are really doing. I think we're doing these processes more occasionally than we mean to. I think this is especially important in AI. You have to talk about AI at the conference this year. Agents are making more changes. Agents need to they'll make a change and then they'll say, oh, let me go check if my change worked, right? And they need to be able to have an immediate feedback loop. And you don't want to have to necessarily set up a development environment for the agent. And you don't want the agent to use the same development environment you're using, because surely you have a dozen agents off in the background doing different things for you. Some of them not even triggered by you. They're on they're responding to messages coming in from Slack. The AI is going to become more, right? So I think continuous is important. The I stands for integration. What does integration mean? You can go look this up, and I think I did. It's in this blog post here. The idea is to detect all of the regressions that are going to happen when your application is all running in production, including all the different services. And microservices made this problem way worse. I think probably early 2000s is when this term continuous integration degraded into really being continuous build, because everybody's just testing their microservice. And you'll say, oh no, it's okay. We have a contract. The contract says we receive this GraphQL query input and we return this JSON output. And then, of course, things break anyway because timing matters, order of the results matter, all these things that weren't in the contract. Again, from the Flamingo book, there's this guy Hiram at Google, Hiram Wright, who worked on the C++ team, and he has a principle called Hiram's Law, which is any observable behavior change of your system is breaking for somebody. And there's the famous XKCD about the spacebar heating, right? If I hold down my spacebar, it warms up my CPU, and I need that to keep happening. So I think unless you can actually, if you have an outage across multiple services and there's no way to write a regression test for that, then you're not doing continuous integration, right? And to be fair, a lot of microservices like the Go team and the Python team, they all have different stacks. There would be no real convenient way to write some sort of orchestration across all of that, but Bazel is exactly that thing. So we finally now have a real way to orchestrate actually integrating the software and then testing the result of the integration, right? So instead of integration being something that happens every couple of weeks when you ship to prod, it should be something that can happen on every PR. And this is just sort of your basic DORA metrics. As an industry, we're all trying to get better at this stuff, but Bazel has a major part to play because we can do this better than everybody else. So we should make CI work really well. There's a bunch of stuff about making CI faster. And so let's talk about that. And I'll go through a few different examples, and we can go back to the Bazel this Bazel examples repo. So first of all, we can do a plain old GitHub workflows, GitHub Actions, sorry. So there is a repo under Bazel contrib, funded by the rules author SIG. This gives you an action that can cache certain things. Okay, fundamentally, what's the problem with running CI? Running Bazel on CI is that Bazel is great at being incremental and it's horrible when it's cold. So the goal here is to try to make it less cold. Now, what are all the different things that can be cold? Okay, well, we'd have to go back to the Bazel 201 course about how everything works inside. Probably most of you know these things. So there's the first one here is Basilisk. So the Bazel binary itself, it's 43 megabytes, generally pretty good. It was actually when I was at Lucidchart, we were fighting with the Bazel team to make it smaller because they couldn't adopt it for JavaScript. I don't know when, 2016 or something. So they stripped out a bunch of the JVM. So yeah, that one's a small win. The disk cache is pretty huge. So disk cache is a way to get basically a remote cache running locally on your computer. So it actually goes through all the same code paths inside of Bazel that remote caching does. And as of Bazel 7.4, I think it has eviction from the disk cache, so it's no longer as scary that it's going to eat your whole disk. The things will get removed from it. So one of the things that this setup Bazel action supports is persisting the disk cache using just the plain old GitHub Actions artifacts, cache store, and then restoring it onto a new machine. That means, in theory, you can get action cache hits from local, even if you don't have remote caching, remote execution set up. Repository cache. If Zhudong was in the room, he would tell you about the new feature that he's been working on. So previously, repository cache was really a downloader cache. So this is anything that Bazel uses its fetch API to grab. So that's like the download and extract API inside of the repository context. Like LLVM is a great example. Unless David manages to help us all get onto a smaller one, we're all downloading this massive thing all the time. We could stop downloading it all the time. That would be nice. However, the next thing we do is extract it. Well, that's not part of the repository cache because it was misnamed. It should have been downloader cache. Now there's a new thing called repository contents cache, which should have been called repository cache. Naming things is hard, along with off by one errors. Those are the 3 hard problems in computer science. Haha. So in like Bazel 9, you can turn on a repository contents cache. I imagine we need to add that to the setup Bazel action. That will help so that not only can you avoid downloading another LLVM, you can avoid extracting it. And of course, there's a bunch of repository rules that do like actual like work. Some of them questionable whether that should be happening in a repository rule, like the create universe stuff. Yeah, go ahead, David.
I think it works in 8.4 as well.
Oh, they backported.
I think enough
Okay.
bugs were fixed that you can turn it on.
Okay, cool. 8.4. So yeah, it's definitely something to try, the repository contents cache. So these things can help somewhat to get, like, think about all the files on the disk that Bazel is going to like touch when it's trying to do a build or test everything in your repo. We're still missing a big one here, which is Bazel puts a lot of caches in memory in the JVM. I'm sure everybody knows that there's a big fat Java server running in the background until it idles and times out and gets shut down. There's a talk at BazelCon tomorrow afternoon around 3 or so from Shahan, assuming flights work, about they now, at least in Blaze and certainly at Google, are able to capture the results of the analysis phase, which is one of those big caches that lives inside of the JVM, store it, and then restore it when Bazel restarts. So you have a fresh JVM, you can get that cache back. There's a lot of other caches in there. I think it's fun to go to BazelCons and sort of play a bingo game of like, are they going to say that they're making Bazel faster by introducing more caches? Or are they going to say that they're reducing RAM overhead by removing caches? And yeah, I mean, there's like no good answer, but we're trying to find, or they'll add flags and it's up to you to figure out which one is right. We all know it's going to be that one.
More flags.
More flags, yeah. Okay, so yeah, in theory, even the caches that are in the JVM, we may be able to restore. So all of this is to say, if you're running CI just on a plain GitHub Actions, you're going to have ephemeral runners, which is this idea that GitHub provides you a runner machine, and a bunch of other CI platforms do the same thing. BuildKite will now host runners for you. CircleCI has always done this. You're spending CircleCI tokens. Somebody in your budgeting team cares about how much you're spending. For some companies, it's like a crap ton of money. Running that on ephemeral machines may get better in the future. Today, this is still not great. Like, this takes a while to download these things and put them back on the machine. So there are a bunch of other strategies that you can use. So of course, remote cache, remote execution. The remote cache gives you the benefits of the disk cache, but without having to wait to download it to the machine. Probably everybody should be using a remote cache. There's lots of options. There's commercial ones. There's capable open source ones. If you're using free open source, the bookgr Bazel Remote seems pretty popular. I've got a couple commits on there. It's still not going to help you with the problem of a warm Bazel JVM, right? So to be fair to all the vendors, there are a couple options you can do here. I'll show you the one that we've done in the Bazel examples repo. First, I'll mention, BuildBuddy has a solution for this. I'm not going to try to explain it in detail. I'm no expert on it, but like they're using Firecracker to snapshot the Bazel JVM in the same way that you could like hibernate your laptop and then like resume later, which used to be a thing before they all just sort of sleep magically. But I remember having to like hibernate a laptop. So you can basically like put the JVM into cold storage and then get it back out later and it's still warm. So that's cool. I think they had to make some kernel fixes. I don't know if those are like upstream to the mainline kernel. It sounds like complicated science project. It's pretty neat. EngFlow provides remote execution, remote caching. That's an option for, and I think has also an option for having like the warm Bazel machines running. The one that we're running on this repo, just because I'm the person standing up here, is, so Aspect has one of these too. So we have an Aspect workflows. So the way this one works is we've got a YAML file that just like briefly says like what we want to run on this repo. And then behind the scenes, we have some infrastructure running that keeps a pool of warm Bazel machines around, and does basically the same thing the setup Bazel action does of restoring files onto the disk before that machine takes a job. But then there's a bunch of other things you can do there to auto scale that pool intelligently at the right time of day, monitor the health of those machines, and bring them down. I see the last thing I submitted here is red, and red is good in demos. Oh, it's red. It's not red on BuildKite. So we're using BuildKite for our build. I can show you. I'll just briefly show. We've got a web UI that makes it quick for me to go find my recent builds. Nope, it normally does. Let's go to Build Barn. So Build Barn we're running on PRs here. So if I go look at a PR, we should see like how these Bazel tests are running. This is going to go to the same place. It's conference season, so we're all shipping stuff, right? Not that's okay. I'm resilient. Live demos go that way. So what we're doing here is like, and you would have to do the same thing, right? So I'm going to try and speak generally. If you want to have persistent CI runners instead of ephemeral ones, you will have to manage a disk image, and you can actually bake some dependencies into the disk image. You could even decide, like I said earlier, like let's not bring all the dogma of Google 3 with us. You could decide, hey, you know what? I'm going to put LLVM on the disk image, and I'm going to explicitly not set up a hermetic CC toolchain for my Bazel builds. That can work if you've somehow managed to guarantee that you do have the right thing on the machine in all the places that you run. Maybe all of your developers are using remote dev, and so they're on a container that has that set up. Then it could be okay, right? You could containerize your build. Whatever you have in this base image needs to be enough to satisfy both, Bazel being able to run at all, and then whatever tools it's going to spawn. So like you probably need like libc on the machine, right? Like it's pretty hard to like really make the build 100% hermetic. If it was 100% hermetic, we could use distro list that has like busybox plus a kernel, and that's it. Then you're going to want to keep track of the history of your job. So like on Aspect workflows, what we do is sort of give us a pointer to previous jobs. The reason is that like the trade-off we're making here, until Bazel is like amazing at ephemeral machines, we're giving up something by having persistent machines. The thing we're giving up is isolation between the jobs, right? We're trying to host a reliable service on which all of our customers come and throw like poorly thought out AI code that is like just trashing the machines and leaving them in a bad state, like booting like five or six Docker images and then like not bothering to clean them up, right? And so container D is filling up. Like literally you got to look at the number of inodes used, because I mean, at Google, we increase the number of inodes, but like surely like there's some maximum in the kernel of how many inodes you're going to keep in the file system. I don't know. File system level stuff is like definitely in your purview if you're trying to operate this service, right? And then being able to take machines out of circulation if they fail some sort of a health check. You want to be able to do something like that. The other thing you need is to avoid. So I mentioned the analysis cache being something that we don't want to lose, right? We want to keep it warm in the Bazel JVM. When do you lose the analysis cache? Every time you change a flag the wrong way. How do you change a flag the wrong way? Well, you didn't look through all 800 of them and get the right values. Okay, it's like silly, but until the common, so in the Bazel RC file, you can list common space something, which makes sure that the flag gets applied to all the right places. Awesome work by Fabian and some others in the community for getting that in. That helps to avoid this. But there are a bunch of other flags you can get wrong. So like one thing we're doing here is like trying to set a bunch of the flags, not just like, if you're using one of the remote execution, remote cache systems, that will give you some flags to set to like point to the remote endpoint, but there's some other flags that are related to remote execution that you're going to want to set properly. And then there's a bunch of flags that are just, well, like what's the right modify execution info flag for tar files? If I'm on remote execution, I want the tar files to say remote. If I'm not using remote execution, I don't want the tar files to get saved to the remote cache at all, right? So setting flags correctly is another thing that sort of is your job as the operator of these CI machines to be involved with, to keep them fast, right? And then there's of course telemetry, keeping track of like, are my builds staying fast over time? In this case, since we're using BuildKite, we can go see the list of agents that it's running, and you can have different queues. And I'm sure like the Bazel team themselves is splitting up the Bazel builds over a bunch of shards on BuildKite. So you could set up something like that. Underlying any one of these CI systems, though, is the question of like, what machine are you going to get, right? And here's the one that did this BB storage build. And how quickly is that machine ready to accept a new request from Bazel, essentially. Okay, so that's kind of the state of the world. We basically have to do some complicated things on CI to get good turnaround time. We should do, probably today, almost everybody needs to be using persistent runners, like at a big scale if you want your company to have fast CI. I don't, I mean, Alexi's around the conference. He's got an orange shirt. He's doing some interesting stuff with ephemeral runners, but then like reattaching a network drive to them. So like some sort of fuse. I'll let him explain it. Much better than I can. So there's a bunch of techniques, right? That all of us have been trying to apply to make this stuff faster. Okay, so the last part is about build cop, keeping it green. I have a whole section on this. So in a giant repository, at a certain scale, you will reach the point where you cannot have a green. In fact, in Google, like we like one of the first things we needed was to like run the analysis phase over the whole repo. So like sort of Bazel query ... There was no snapshot of the code base at which all of the Starlark code was syntactically valid. So you can't even like you can't even produce an AST of all of the Starlark code in Google 3 because it's not valid, right? And by the time you fix one, somebody's broken like one or more other ones. That's not a great state to be in. And if you can at all help being that kind of scale, you should. So it's very different. So like what happens in practice is, okay, well, if the whole repo is not green, then maybe just my app is green, right? So I'm going to ship when my app is green. So basically every team has either their own CI setup or there's a shared CI setup, but every team kind of defines a view over the parts of the repo they care about. And at Google, we had a thing called blueprints, which is basically this view. What subset of the test targets do I think, if they're green, that probably means my app works? And I'm saying probably because like it was completely unprincipled, right? You would have a production outage, you'd go back, you'd be like, you know what the root cause was we didn't run this one test before we shipped. And then like a few weeks later, the dependency graph has totally changed and it's still wrong. Everything that you possibly can imagine that you would want to do in your CI system to try to pick which tests to run for a given set of files, which tests need to be green for a given release, you're wrong. It's like impossible to be correct. You can be kind of correct and then like eventually something goes wrong. Sorry, one sec. So the easy and there's an important thing to note, right? Which is that your build is red because you exercised some shared library. The other team B, their build is green. They use the same shared library. It so happens their test didn't tickle the part that's broken. Should they ship even though they depend on a library that has a known breakage in it? They probably shouldn't. Is anybody doing the sort of graph analysis to say, hey, don't ship app A, I forget which letter I used, because we know that there's some library that it depends on that's been observed to be broken in somebody else's build. It's so difficult to get these right. So the easy answer is you test ... You make Bazel fast because it should be pretty fast to look up cache hits, especially if you have like a persistent machine that's in a good state to like, it can very quickly start making cache lookups into the remote cache, and it can get 100% of the build done quickly enough. That's the much more feasible answer. And if you have to do something more complicated, please like fight back against the need to do that until you reach a scale where you just simply cannot get a shared green across everything. How do you preserve your ability to have that scale longer? Is you have the role of a build cop. And this is sometimes a cultural change. So you need somebody who is both empowered and tasked with anytime main goes red, and you could have a merge queue. Even with a merge queue, main can still go red. There are tests that depend on some service to be running, and it stopped running. Flakiness has increased, right? And so it got through the merge queue, but now it's like, that was a roll of the dice, and we just haven't gotten another roll of the dice that's green since then. So you have a person whose job it is to revert bad changes. And you have engineers who are like, wait, I don't even know who you are. Like, this is the team that you didn't even know worked at this company. You have to be allowed to revert their changes, and it goes green again immediately. And then they work on how to roll forward, right? And like figure out what was wrong. Maybe somebody was missing a test case. They'll be frustrated by that. But the nice thing is, like, if you can do that fast enough, it's essentially the rate of repair compared to the rate of breakage. If you can fix things faster than other people are breaking them, then you can keep your monorepo green. By which I mean you can keep an overall green signal. Another thing that can help is to have a last known good or stable ref. So in CI, every time you have a green result on main, I'll talk about how you should do continuous delivery. One of the things you can deliver is actually just a ref on the repo that says, hey, unless you need to be cutting edge, you should rebase to here, right? And you change your developer tooling so that most people are indeed rebasing to last known green. The advantage is you've reduced the severity of red main a lot, and you've reduced how many people are going to be depending on the commit that landed, right? Because the commit that landed, it adds a new API and it breaks a test. Somebody now lands a commit that depends on the new API within 10 minutes. Now you can't revert, right? So having engineers not observe the red state can be really helpful. Okay, question.
Sorry, I was just gonna ask out of tangent. When you were at Google, why was it the case that like there were syntactic errors in Starlark? Weren't those caught before PRs were merged? Am I being naive?
It's, I think, a fair question. I think part of the answer is that there was a before times when things were allowed to be broken. Now we want to institute a new thing that's like nothing's allowed to be broken. How are you going to, like, I had showed this little diagram with like a ratchet. You can't turn it one tooth. There is no amount of leverage in a repo that big to turn it one tooth and get everybody to agree, like, okay, at this point it's green. Now we're going to keep it that way. Yeah.
You mentioned like Starlord broken, so that was when it was already Starlord, not arbitrary Python code in build files.
Right.
Because there was that phase.
Yeah, I mean, yeah, Bazel Starlark grew out of like Python minus minus essentially, which was, oh, there's all these things we can't do to make Bazel faster because you can have for loops in your build file. I forget why that, no recursion in your build file because they want to be able to like limit stack depth or detail. I forget what the optimizations are, but
I do want to just say, I apologize.
Yeah.
I didn't mean to laugh at you.
Oh, no,
I
no, no.
was laughing because I also went through that with like Google in the past, and yeah, there's a lot of that stuff.
Yeah.
I think also it comes down to like you also could imagine that like, well, something changed maybe in like some form of like a downstream dependency or something changed that didn't like Alex said, like it's so siloed that section never got run. And so then later on, like this is older code that nobody pushes anymore.
We have that in certain
And so it's
circumstances.
when you try to run it all, it's like, oh, suddenly this is broken, but nobody made a direct change that ever got picked up.
Yeah, we have a Bazel unified build that's supposed to build everything, but doesn't actually build everything.
Yeah. So, and maybe I'll add a little more to this also for the recording. So, there's a lot of companies that use Bazel diff or target determinator to look at the files that were changed and reduce the number of targets you run. There is one very, very legitimate use case for this, right? Which is I rebased on main. Main landed 1 minute ago. It has a 15-minute test that's a cache miss. The cache doesn't have a hit for this. I'm going to have to wait 14 minutes for my build to go in, presumably because I need a cache hit for that because I'm running test ... That could be solved by using my last known green, right? I should never have rebased on something that's a minute old. Okay, but like some people observe this.
Yeah.
The other reason is just it's a workaround because our Bazel's slow, and if we put this thing in place, then we'll just put less load on it, right? So like our remote cache isn't scalable enough, and we can reduce load on it. It might be something you have to do. I mean, there's trade-offs. So here's the downside: is you're running something like Bazel diff. I don't mean to pick on them; it's a great project. Benjamin Peterson's talk from a few years ago at BazelCon like explained the whole principle behind it, which is like a lot of Bazel queries. It's very hard to actually get right. In fact, it's impossible to get correct. And so if you look at the documentation for Bazel diff, it will say something scary like, oh, and then you can also kind of seed this extra thing, which will cause it to throw away and claim everything's affected if you change the workspace file, or if you change this build file that has like a macro that something doesn't understand, right? And repository rules in particular, because of the fact that they are non-hermetic and run outside of the action graph, can have different results on different builds that would invalidate a bunch of the graph, and it doesn't know about that, right? Target determinator is a little bit more correct because it uses Bazel C query, but that also makes it slower. It needs to do a query at the before and the after state. Anyway, the downside is if it's incorrect, then what happens is something is read on main, but you don't know it until it gets tickled again by something else that could be weeks later. And in the meantime, you're shipping applications because you think main is green. And like the analysis of like correcting that, I think even the first time you run into that, you should be like, okay, like why can we not just run all the tests every time? Because that is brain dead simple. I do Bazel test ... It's green and I ship. Like,
Bazel diff is great for local development.
yeah, I think it would be awesome if we had something like Buck has an affected verb, right? Like I think we should be able to do affected, as an input to things, but it is hard to get correct. Okay, quick one here. So I talked about, let's say we have a mono repo. Bazel, of course, doesn't require mono repos. You could give a whole talk about techniques for allowing it to operate over more than one Git repo. I said you should have a mono green. Okay, so everything is green. So now what versions do you ship? There's a lot of options. So here I'm just giving one recommendation. So you could let teams continue to version all their own stuff and pretend to follow semver, but they can't follow semver in a mono repo because application A is going to ship a major, application B is not going to. They both depend on the same library where the change needs to be made. Okay, well, like in a graph, you can't, like everybody has to step together if one piece of the graph is reachable from these two applications and needs to make a breaking change. Okay. for most of us, like Semver is not even that interesting unless you're like literally shipping to customers. Like you have like an SDK that you need to publish as part of the output of your build, and your customers expect to know when you've made breaking changes and not. Okay, that's a valid reason. For most of us, like if we're shipping microservices, things we host ourselves, I recommend doing a scheme like this. I've got a longer blog post. Basically, the recipe is you make something that tags the repo once a month. So you probably, anybody who's had to deal with Git getting gigantic, like if you have thousands of engineers in a Git repo, one of the things that makes every Git operation slow is the number of refs. And if you let teams create tags on every release, you will have like this explosion of refs. You have to do a Git GC and a Git prune. And even then, like it's hard to, like those refs are still load bearing in some way. So if you tag the repo every week, and I have some examples here that do it, then all you have to do is run a git describe, and this will go into your workspace status command, right, as part of stamping under Bazel, that counts the number of commits so far that week plus the SHA you're at. So you get a version that looks like this. The nice thing is, at a glance, and like Aspect CLI is shipped with this versioning, you'll see it in more places. So you'll see, okay, this was like February, March or so, because it was the 7th week of 2023. So I know approximately when this version is from. I know whether it's before or after some other version, right? So I can look at the number of commits and I immediately have like a monotonically increasing version as commits land. So it's very easy to reason about before, after. And like the reason this matters is you're firefighting, right? As soon as you think about like versioning and stamping, the thing you're preparing for is an outage in production and you're trying to figure out what happened and where the software came from. So that's why we're trying to make our reasoning here is really easy. Finally, like plus git SHA, well, obviously we want to be able to hop to the source control state at which this thing was cut. Like I want to see like, okay, well, what was the content of that RS file at that commit, or that release? And so it's easy to find. Notice that plus is not allowed in Docker tags, so somebody please yell at them. But you can change it to a minus. Technically by Semver spec, the plus is correct for build metadata. The other nice thing that's nice about this scheme, it's not Semver, right? Like it doesn't distinguish between whether it's a major or breaking change. But it looks enough like it that a lot of monitoring tools will kind of expect to format version numbers this way. So it can be kind of handy. Yeah.
So if I tag the cache, will it be possible to version the cache for every 90 minutes?
Version the cache. So Bazel's action cache is versioned by the digest key of each action, which is just the input files, the command that you're running, and the environment. So there should be no reason to consider whether you want to like snapshot that at a given moment.
Remote cache?
The remote cache, yeah. So the remote cache is keyed on like the contents of the thing that you want to build, right? The inputs to the action.
When we make changes, like just override the cache.
Well, so most remote cache setups should be big enough that objects remain in the cache for a long enough time that you're not getting cache misses later. So if you find that things fall out of the cache because you made changes to the code, you probably need a bigger cache. Or different retention policies for artifacts. Yeah. Incidentally, I hope everyone goes to the rules image talk. We're going to need to add retention policies to the remote cache because Malta's improvements rely on being able to push to the registry from the remote cache. You don't want things to fall out of the cache before you get a chance to ship them. Okay, I'll show stamping really quickly. Maybe I can show that in an example because there's not that much on the slide. I guess I'll just go back to the Bazel examples repo. Okay, so the key about stamping is we don't want to do stamping is a way to introduce intentional non-determinism into your build, right? Let's take this Go image over here and I look at the build file. So I have some OCI image here that I want to push, and then I want to tag it with the tag, and in this case it's like I have a fixed tag because I'm pushing it to an ephemeral registry. I might want to stamp this with the actual tag of the software that I'm running. Sorry, I thought we were doing that in this one. Let me just find an example that does. I don't know if this is a great example, but it definitely shows shows what you can do. So the bunch of rules are stamp aware. And every rule that's stamp aware should give you the ability to put a stable thing into that stamp variable to replace the dynamic thing. So like in this case, I chose 000 placeholder. That's the substitution that will happen only when stamp is turned on. If stamping is not turned on, then this rule will not do a replacement, and so it will just leave this text as is. So this is going to come up in a second for continuous delivery, because if we allowed our builds to be stamped, we would get cache misses. It means that even if you're only stamping sort of your release artifact, hopefully, like I said earlier, we want to do true continuous integration. We want to have some tests on the actual artifact we ship. Those tests are going to be a cache miss every time. In this case, the timestamp changes, right? So every time Bazel sees this thing change. You can read more about stamping. There's like a stable and a not stable. So this one doesn't have stable on the front, which means really this one changes. Like every time this rule gets run, it will produce a different output. That's still bad for caches. It's still bad for determinism. We don't want to do this when we're running unit tests. However, when we're shipping to production, we turn on -- stamp, and then we will have an artifact that like has the version control information embedded in it. We should only do that when we're going to push things to production. And I did say I was going to end early, so I'm going to try to cut a little bit more out of this. So, Bazel doesn't really know what to do other than populate the output tree. So it's kind of like, oh, I don't know, what do you do next? So you did Bazel test ... and it's green, so that's your signal that like, okay, we could do continuous delivery, we could do continuous deployment at this point. Delivery just means publish the results somewhere. So this is a copy of the status files. So they're actually just sitting in the Bazel out folder. You can just like see the contents. So what we want to do is, first of all, when do we stamp? So only when the -- stamp flag is set. Finding the releasable artifacts. So this is where you could do Bazel diff and look at the commits that were changed, right? To figure out which of the, let's say, OCI containers in my repo do I want to push. Do you want to push all of them? Well, that's potentially slow, especially if they're stamped, then they're going to have a different digest. It's also going to confuse the release engineers, because now when they go to like promote the release to production, there's like 50 releases from today to compare, and it's much harder to get the right one. So what we do in the Aspect platform is we have a Bazel C query output that allows us to get like the executable hash of all of the pushable targets. And when that thing changes, that means that the thing can be pushed. Let me see if there's an example in the repo of that. I'll just show you the config file. That's an easy way to see it. So basically the configuration for delivery, and you could do something similar, don't have to use our platform. So when a change lands on one of these branches and is green, so main or release branches, then you got to figure out, okay, do I want to push deliveries on every time or have engineers do it manually, right? And you could easily set it up for engineers to do this manually using something like GitHub Actions, where there's a workflow that has some input specified, and then when you go to GitHub Actions, it gives you a little form to fill in, and you can say, yeah, at this commit, I want you to deliver some stuff. You set which flags are turned on. So in this case, -- config equals release. We'll turn on -- stamp, as well as maybe -- compilation mode opt, and whatever else is important to differentiate our release artifacts from development. And then we have to figure out which are the deliverable targets. Okay, so this is a Bazel query expression. So in this repo, we're saying anything that's an OCI push rule, I want you to automatically Bazel run that with -- stamp turned on anytime there's a green build on main. And then we have automation on the platform to do that, right? You could write something similar in GitHub Actions to do that. So the nice thing, and sorry, there's two steps I missed here. So one is, why do we do this at all? Well, the whole point of continuous delivery is that it should be impossible for engineers to accidentally ship an artifact that has local changes that weren't committed, because we want supply chain security and also not to just not mess up. Why do engineers do that? Well, we're talking about production firefighting when we talk about stamping. They are trying to get something fixed as quickly as possible, so they'll just like YOLO it into production and just start like doing changes, not going through the CI pipeline, because CI is too slow. And like, it's very difficult to build like a reproducible, engineering practice around shipping stuff that way. Like, you don't know what changes ended up working. Did you remember after that release to then port the right fixes back into the repo? Or like next time you push, are you going to like forget that you had some, hot fixes live in production? Like, I'm sure all of us have like, I can tell you this, but if you've had the problem, it will feel much more natural to avoid it, right? So we want our CI pipeline to be fast enough that I could literally go and make a change to that Go file, and within a couple minutes, the new artifact is sitting in the registry, ready to deploy, and it's not really that much faster than me going and hacking into the thing in production. And so I'm actually willing, as a product engineer, even though there's an outage going on, to go through the normal workflow. The other thing that we're not showing here is at the end of the test step, we basically upload a manifest of here's all of the targets that match this query and the hash of the executable. And we basically are treating anything that you can Bazel run is something that the system can deliver. And that's an arbitrary thing to pick, but it's very convenient because it means all the logic for how to do the delivery lives in the repo or the rules that you're using. You could write custom rules. We have like an S3 push rule in rules AWS, for example. And then, but the CI system can automatically push everybody's changes. And so there's no per team setup for how they do continuous delivery. Everybody does it the same way, right? Continuous delivery is one of those DORA metrics that we're all being asked in developer infrastructure teams to improve across the whole organization. So if you can get everybody doing continuous delivery on one, a file like this, right? Basically, like here's the logic of how continuous delivery happens across the whole organization, then you can improve this metric for everybody and teams don't have to think about it. Deployment is a whole separate step, right? So you've delivered the artifacts to the to the registry. Now it's still somebody's job to figure out, like, are there human steps to perform before you actually like cut over the new version to be live? Okay. So I do want to leave enough time for some open-ended questions. So the last 4 sections here is really like how do we keep it this way? And this is a little bit of an answer to the question earlier. What if I have like 2 people who are doing it a different way? And the first observation is that your teams are understaffed. So like Urs Hotzel was the VP at Google in charge of developer infrastructure, and people would complain like, oh, like there's only 5 people on the team that manages the continuous build for like all 80,000 engineers at Google. I don't know how many they have now. That was certainly how our team felt. And the answer was, well, if the dev infra team needs to double when the number of engineers at the company double, then you didn't write scalable developer infrastructure. Your headcount should be flat. And I would say you could make the argument that like every time we add a new language, maybe we deserve a couple more headcount to like keep all the things working. But like it's really expected in like most companies expect to like infrastructure teams to stay small. In order for that to work, like you have to keep the uniformity. So if you're going to support a large number of engineers and companies are all looking to cut costs, like maybe that's fewer new hires. Let's not talk about whether that's fewer people who are already at the company. So like we have to maintain our ability to like operate at scale. And we have to protect that. So like basically it's preventing unique snowflakes from forming and telling people, no, you can't do that because then we won't be able to support you anymore. You can do sort of a walled garden, and then the people who live like I don't want to come across mean to anyone. So some people like to go live out by themselves and are self-sufficient and live off grid, and like I totally respect that lifestyle. That's a cool lifestyle, right? Most of the people in your mono repo should not be doing it that way. So like you got to keep them in the walled garden in order to have your leverage, right? So like that's a little bit of this metaphor. So and engineers came from smaller teams, right? So like let's say you're doing a mono repo effort, but all these engineers at your company previously they would take their laptop to the well. I'm sorry, the metaphors are getting very mixed. It's the end of the day. So because they need water, and like you go to the well to get water, you live off grid, that's normal, right? And then they bring the water back to their desk, and then they keep coding. But in a mono repo, like really, what all of us are is we're like the plumbers, right? And we live in this big city of like bigger companies that are adopting Bazel, and like let's talk about water and not sewage, but both of them have the same sort of problems, which is that we try to keep all the pipes working. Engineers just turn on the faucet, right? We go to their apartment. We're like, okay, we've set you up. Here's your apartment in the mono repo. Here's a faucet. They turn it. They're like, wow, that's great. I'm not going to go back to the well anymore. They have no idea how it works, where the water comes from. And then if the water stops coming out of the faucet, then they completely freak out, right? And most of us would if like we turned on the faucet and water didn't work. What's more, like the municipal services people are not only providing like safe drinkable water, everybody goes out and buys bottled water because they don't trust them. And then when they come and do repairs on your street and like there's a street closure because they need to get to the water main, everybody like abuses them. I'm going to do a podcast episode with this guy I met. It's hilarious how similar it is to our world of being plumbers for developer infrastructure. So I don't know. To me, this slide just makes me feel better. But it also means that like developers have to change their behavior. Like we have to they need to realize that part of living in the mono repo is that you're going to take care of a bunch of stuff for them. They're not going to have to go to the well, but they're also just not going to understand how the faucet works and they shouldn't need to. And if they want to go like hook up some like crazy weird like water recirculator in their apartment, maybe that's okay. But like if they want to like change the whole water infrastructure, that's just not like appropriate, right? And some of them are enthusiastic. You can give enthusiastic contributors ways to be part of the project. You can say, hey, maybe if your manager is okay with it, come work on the municipal water supply, but it has to work for everybody. You can't just work for your team. Preventing weeds. Okay, so this is a little bit of a gardening metaphor, but like weeds are really easy to pull out when they're tiny. It's kind of fun. They haven't taken hold, right? The roots are easy to pull. You can do this in a monorepo if you have the ability to detect that people are making mistakes quickly. Here's an example. Engineers realize that, oh, you know how to make your build succeed more of the time in Bazel is you just have deps equals and then you paste like the entire list of third-party dependencies there, tends to make your build succeed, right? If you can detect it, and people make, like the Bazel's complicated. A lot of engineers are novices. They're just trying to get their work done, right? So you can't really fault them for like doing whatever is near at hand to solve their problem. But we do want to be able to detect that. And just like weeds, if we detect it quickly, we can fix that. If everybody in the repo is doing it that way, and now like the pattern is encoded into some tooling that also expects that the depths lists always contain everything, like, it's much harder to fix, right? Because of the network effect. So as an example there's a bunch of Bazel flags you can use. Visibility is a classic one, right? So if you have, Google started off with visibility public as the default, which meant everything could depend on everything, and so it did. Now, the problem with the dependency edge is in the same way that a microservice can't be more reliable than the services that it calls out to as part of its call stack. An application can't be more reliable than the library it depends on in the monorepo, because if those library maintainers all went away and there's a critical 0-day vulnerability, or like they just need to add a feature to it, nobody's around to maintain it anymore, the critical service now is like, sorry, like now you end up with a copy of this library that you maintained because the people disappeared. So visibility, hopefully everyone already, they fixed the default first of all, so you have to put visibility attributes, but one kind of weed in your repo could be everybody at the top of their build file puts package parentheses default visibility equals visibility public, because that's a quick way to make everything work. So you have to put some effort into like fixing that one. -- sandbox default allow network. One of the 800 Bazel flags that's kind of handy. So that one is saying like for sandboxes that support it, don't allow the build action to arbitrarily go out to the internet and do stuff, because that's another thing engineers are likely to do if they can, is spawn an action under Bazel and then do a bunch of stuff that really should have been a previous action that Bazel was able to run hermetically and produce the outputs, and like they were able to get around that by writing a gen rule that does a curl. Okay, so like gen rule doing curl, not so great. So you want to be able to discover those and prevent them. Yeah, and then some more about dependency edges. Okay, last section from the prepared part at least is patching. Sorry, yes, please, question
I was
first.
just gonna say, I don't need to beat the AI horse, but like I feel one of the things that I've seen is like sometimes people have weird issues with their build, and then they're using some sort of agent, and the agent uses its vast repository of trained knowledge to use some weird Bazel flag or put this weird attribute here. It'll fix the issue, and in actuality, it's like the path of least resistance, and it's very gross, and they shouldn't be doing that.
Yeah.
Do you have any recommendations for how to get people not to do that?
So the old answer is linters, and Buildifier is the Bazel linter, and I've only met one person who's tried to add lint checks to it. We should all send this person a peer bonus. Maybe they will add more, or like the rest of us could. But like in theory, linters are supposed to detect bad coding patterns, and most programming languages have linters that detect a bunch of like obvious mistakes people make. For AI specifically, well, you have this problem that open source is like, there's not a signal when you're training AI systems on whether the code that it's reading is a good way to do it or not. And so there have been a lot of models trained on questionable patterns from open source. The security industry has lots of horror stories, and like, they're probably better monetized than the build industry. So like go talk to security people about how many security vulnerabilities got introduced by reading some code that they shouldn't have.
I think it's difficult because, like, in theory, code review is supposed to guard against this, but the reality is that most teams don't care about Bazel, know very little about it, and so it's like, okay, this fixed the issue and this helped us ship faster. Let's
Yeah.
do it.
Yeah, I think it's incumbent on the whole Bazel ecosystem, and also like rules maintainers and the Bazel team themselves, to also just improve defaults. Bazel's not great at this today, but like the fact that there are so many things to trip over and then developers have to ask the AI to like give me a remedy is like, it's already kind of too late. Yeah, but that is the situation we're in. And yeah, I mean, a lot of times like the AI will suggest something, they'll try it, it doesn't help. Then they figure out the right answer. They leave the thing in that didn't work, right? I mean, sloppy engineering has always been around. So yeah. Question.
Just comment on that. Do you think also having like Gazelle working for use case, if it's for as much as possible, delegate to Gazelle,
We
can
can
reduce
consider.
that?
We've considered Gazelle, but I think one of the biggest reason I wouldn't adopt it yet is because I want people to think about things like visibility and proper attributes, things like that, and to just give them a solution feels too. It doesn't feel right.
Okay, so that's interesting. Like, should we force our engineers to care more about the things that we care about? I don't know if that's practical. Like, maybe some of them will, a lot of them won't. I think it's better in general if we make it so good that they didn't have to think about that thing.
We give them tools to help resolve common issues, but we haven't gone so far to like totally generate the build files. But that's a whole separate conversation.
Yeah, well, there is another thing that Aspect provides, which is an easier way to write new Gazelle extensions. So this is part of I've got some books, by the way, in the back. Before you leave, we've got some little comic books. Basically, like in Starlark, we can now extend Bazel with tasks that will sort of teach it additional things, as well as Gazelle extensions that are easy to write. So in this case, like there is now a CC Gazelle extension. I wrote this before that. Like it's just a quick way to register some rule kinds, and then this can actually have some hard-coded things like, oh, in my repo, I get SQLite from here. It adds some targets, and I'm breezing through this way too fast, but it just like, it's Starlark code that can extend Gazelle. And, at the bottom, we're basically picking, okay, well, what are the files we want to operate on? The reason I'm showing this is that, yes, Gazelle actually is a big part of the answer to this. And if it were easy to always spin up a new Gazelle extension for like a small use case, that could be something you reached for to automate the maintenance of build files. And that's part of the reason we're working on this thing. So yeah, I mean, you can give this a try. Like for example, I have a demo where you put a comment that says, I would like this Python main to become part of an OCI image. And then we have a little Starlark extension that generates an OCI image into the build file just based on that comment being present. And yeah, that reduces like the training burden on your developers. It's a little bit more magic. And I do think that leaky abstractions are bound to cause their users to learn more about what's going on behind the scenes. And like, it's great for us to all, learn all the way down to assembly and transistors. And a lot of people just aren't going to. So, but the idea of the platform engineering movement is that, in this case, you're more like the Kubernetes operator team, right? You go over to KubeCon next door. You treat your customers like they have options and they have to pick your platform, and you're providing customer service in the same way that you would run a startup. And you're thinking about it from, you can sort of shift left on that mentality, and like developer infrastructure can be platform engineering too. In the sense of like, oh, well, like and in fact, one of the things here that I mentioned was like, you can keep people in the walled garden, or you can give them a break glass and be like, you can go do your own thing. But the bar is not necessarily that you have to do the last 10%, but you have to be better than them going off and doing their own thing, right? Like you give them the choice of like, if you don't like the infrastructure we've set up and the constraints we're putting on you, you can like go do it yourself, right? And then it's still up to their engineering management to decide, yeah, we're actually going to do that. I'm not saying like every engineer is empowered to do whatever they want, but they have to pick. They should be picking the platform that we're making based on Bazel. Okay, let me say the last bit here. Forking. So forking is the F word. Forks are incredibly dangerous because they are easy to make thoughtlessly. We're talking about like engineers should try harder. It's very easy. Like you're like, oh, I need to make this one line change over here. I press the button on GitHub. It's a green button, and green is supposed to be good. They should make the button red and flashing, right? It's like, oh, I'm going to fork that repo into my org, my private org. I make a private fork. I make my small number of changes. I'm done, right? That was much quicker than like other alternatives. Now what happens is a couple years later, nobody in the company can upgrade to the new version of that library to get the 0-day fix. You are not running the tests for that thing, but you've made other changes to it. You lost the CI pipeline behind it. You lost the maintainers behind that thing, and they understood you've made some decisions in the changes, the patches you've applied on top of the repo that they could have helped you with. Basically, the quick version here is that what I recommend trying to force your engineers to do, first of all, don't like take away the green button. Again, like this is the ratchet thing. Like try to prevent them making any more forks. Um, Unfortunately, like they can also fork it by vendoring it into your repo, right? And some tools make it easy to vendor into your repo. How do you know that the vendored copy hasn't diverged from upstream? Basically, the answer is number one, like clone the dependency locally because you're going to do that anyway. So it's sort of like forking. Okay, I need to work on this code, right? I'm not saying don't change third-party code. That's clearly not the answer. Engineers need to do that. So there's some way to patch it. You make your edits, you do some print line debugging, you get to a working state, you make a commit. Okay, this is the part that everybody does. Now, the thing that I'm suggesting you change is number one, make a PR to the upstream. Maybe at some companies, the like open source posture makes it hard to PR to the upstream. I know. If you're allowed to, give it a try. You don't care if they're going to accept this PR, though. You just want to have public record that I found the following solution to the problem. Okay, the reasons to do that is number one, you're sharing your solution with others. Maybe like, the Bazel community is lots of companies with solutions that are accidentally baked into their private repo. If we could share more, it would help. It also means that the maintainers of the project might be like, oh, you don't need to do that. Actually, didn't you know that this flag is over here? Making fun of the 800 flags. It also means that if they do eventually merge your PR, then you can remove a patch from your local repo, right? And then the key is you should always just check in patch files. And Mike talked about this a little bit in the last segment on Bizzlemod. Like if you just need to run git show, it's actually not hard to create patch files from your change. You stick them in the repo. Most Bazel rules have like a patches list that you can apply. I know like local path override for module Bazel doesn't, but you can always git override. There's tricks to apply patches. Same thing goes for other package managers. So you're changing code from some package manager. Rules Pi that we were just talking about earlier today. Reed has shown that like you can now patch Python packages too, which wasn't possible before. So as much as possible to check in the patch files. The nice thing about patch files is you can tell how many lines they are, right? So you can tell how diverged you are from upstream. They're kind of like sometimes you have to rebase them, which means like you replay them onto the old state and then you rebase the repo and then you produce new patch files. It's a little bit of a pain in the butt, but you're not going to just like accidentally diverge more and more over time. Yeah, and I think that forking is one of the easiest ways that as developer infrastructure we end up having to support a bunch of garbage that somebody else left behind. And it's one of the biggest things that we can do to like protect our future ability to have impact and get promotions and like enjoy our jobs is to like try to prevent engineers from doing the wrong thing. And my takeaway is that the way to do that is to make it super easy for them to do the right thing. So yeah, a couple minutes left for questions, I guess. Again, there's books in the back. We'll be around the conference. Come find us. Yeah, question.
In this workflow, if you then have to make like a new patch, you presumably have to like check out and then apply the existing patches, right?
Yeah, so you're kind of on a fork, except that your fork is expressed in terms of small deltas on top of the original. Right. For long running patch, like I had a 16 patch deep set on top of Rules Python for like a big customer. I just put that on my fork of Rules Python, and then like you can easily script around it and just dump the set of patches out, right? So you're on a branch that's ahead of upstream. Right. So the rebase is your normal rebase flow, but then you don't point their repo at your fork. You check in the patch files. Also means that like if they do a code search in their repo, they can find where the patches are. Like, yeah.
I was gonna say there's a trick you can play, which is you can run git init inside the like materialized repository that will have all the patches applied. And then just hack around in there, make your new patch, and do it that way. So that
yes, yeah. You can basically make an orphan history where you're like the first commit on the repo. You can do a search for like squash all, and it'll be like, oh yeah, you can just make a fresh repo that is the current state as the one and only commit. Yeah, that can be faster. I mean, Git is a tough command line to get good at. Sorry. Yeah.
I know this talk is a lot about like the talking to people and less of like the engineering aspect. I have a question about that. Sometimes like some maintainers are very like open source maintainers are very willing to like work with you and they're nice and they're not too picky and like they'll help you out. Other open source maintainers, they're like it's back and forth like 20 times and they're like, no, I want you to do it this way. And at some point you just raise your hands because you're like, I'm not getting paid to contribute to your repo.
Yeah. Neither are they probably.
Yeah. So, like what do you do at that point? Do you just stay on a patch or a fork permanently, or do you?
Well, I think this is the advantage of this workflow is you just leave the PR up.
Uh-huh.
I mean, the worst case is that there's a stale bot on the repo and it's like, oh, your PR is old, I close it. And you're like, but so Yeah, you are a few commits ahead of upstream, and like this is the nature of open source is that projects get forked when the old maintainers are not around anymore. Sometimes they find maintainers to take over the original fork, and sometimes somebody new shows up and puts it under their own GitHub org. And I think that's actually like a positive like part of how this magical open source thing works. I mean, there are techniques for making it easier on maintainers, but yeah, some of them are like just trying to like throw you a bunch of chores. I like when I'm taking a PR from somebody, I try to like do the rebase, get it across the line, and merge it instead of making them do like some rebase at the end if I can. Um, it's a tough line because as a maintainer, you're trying to encourage people to become more self-sufficient, and the more things you do for them, the less they're going to learn about how to contribute to this repo in the future. And if this is somebody who's going to contribute more in the future, it is actually worth it to like do the back and forth with them. And yeah, I mean, everybody's kind of pseudonymous on GitHub, so it's really hard to make that judgment call. So we snap to conclusions. Yeah, question over there.
So, you talked about a flag running Bazel sandbox or internet.
Yeah. That flag's been around for a little while. Here's a quick tip. So the folks at BuildBuddy made this build registry that has a flag viewer that is version aware and has a search box. Okay, so you go to registry.build. You don't even have to memorize the URL. It's this little flag icon here in the corner. So yeah, the flag we were looking for here was Sandbox Network. So here's all the Sandbox flags.
Can we just replace Bazel documentation with this?
Here you go. Sandbox default allow network, right? You can copy this flag, you can permalink to it and send it to your coworker. And it tells you which Bazel version and the default. Yeah, we will put this UI in the better place. I mean, come to the talk about Bazel documentation.
Oh, there's a talk about
Preview.bazel.build. So we took Mintlify, which we were doing for Aspect, and we took the entire Bazel documentation repo, and we have now hosted it under Mintlify with a good search, and you can send PRs to it, and it is much easier to read and no longer hosted on Google Infra. Yeah, and it's available in all languages, including English. Yeah. Probably the last one.
You're better around Bazel and kind of using that to pull in tools for your workspace. One issue that I've had is like you still have the bootstrapping stuff of like how do you get Jira, how do you get Bazelist, and when there is kind of a place to put other tools, people start putting things in there instead of in Bazel. Wondering if you had any recommendations.
Yeah, I mean, so the principles I described was try to keep people in the walled garden. So if somebody wants to add a tool in some other way, first of all, like how would they possibly, right? They can put it in their README that everybody on my team should install libSSL version 3, and like it is hard to like stop that in every case, and maybe it's not your place to stop it in every case because we want to let people innovate. But again, like you make the good path easy. So if everybody so for Duran, okay, so you have to put it on your machine. Greg and I would love to figure out how to like get it into our CLI, for example, so it's one fewer thing to install. But you can pop up a message in the right spot. Here, let me give you a quick example. So for Git hooks, this is the workspace status command for this repo. So what it does is every time Bazel runs, it checks if you've got the hooks installed, and if not, it pops open a message giving you the instructions, both how to opt out if you really don't like it, and the command to run to set up the Git hooks, right? And then the pre-commit hook is going to run some sort of Bazel format step. So I think a lot of the answer is like try to like pop open messages just to like the small amount of like it should only show up once. You're not trying to overwhelm people, but like, okay, I put the following things on your path. To add more things to the path, click here, right? And yeah, I mean, like if it's good, the people will use it. Okay, we're a little over on time. I'm worn out. Thank you all for listening to me for so long today.